In this video, section 4.4, Applications of Proportions. The first situation I want to take a look at here is similar triangles. So we have these two triangles, triangle ABC and triangle DEF, and they are similar. What that means is that the sides are in proportion. For example, the length of side AC divided by side AB is equal to the side DF divided by DE. Well, we know what AB, AC, and DE are, which means that we can then find DF using this setup. So let's do that. 8 divided by 11 is equal to DF, whatever that length is, divided by 14. We're going to multiply both sides by 14. And that's the length of DF. And if we have a calculator, we can compute that the length of DF is 10.18 units. Alright, let's do another one. We can also find the length of BC. BC divided by AB is equal to EF divided by DE. So that means that, see here, BC divided by AB, we'll fill in the lengths here, that's 8, is equal to EF 19 divided by 14. So BC is equal to, let's see here, 19 divided by 14 times 8, multiply both sides by 8. This cancels out to give us 19 divided by 7 times 4, and if we have a calculator we can compute that the length of BC is 10.86 units. Now I also want to take a look at some word problems. This is one of the baseball word problems that comes up in the textbook. In one season of baseball, a pitcher averaged 5.8 hits allowed per 9 innings pitched. If he allowed 87 hits, how many innings did he pitch? Well, let's think about what we've got here. First, we have 5.8. Let's see what that is. It's hits per 9 innings pitched. 5.8 hits per 9 innings. Alright, if he allowed 87 hits, we're going to use a proportion to solve this. We've got more than just the 5.8 hits, so we should be able to set up a proportion using 87 hits and see how many innings he pitched. 87 hits, how many innings did he pitch? And this is what we're looking for right here. This is what we want. So let's write that a little bit cleaner without all the letters getting in the way. But it's good to do it with the letters to make sure that we have hits on the same side as hits, innings on the same side as innings. So this is 5.8 divided by 9 is equal to 87 divided by I. Okay, what we're looking for is in the denominator. So this means we're going to look at the rule of 3. I times 5.8 divided by 9 is equal to 87. Multiply both sides by I. Now we're going to divide both sides by 5.8 divided by 9, or multiply both sides by the reciprocal. Multiply by 9 over 5.8, multiply by 9 over 5.8. We'll write in the rest of the problem around that. And this is still going to cancel out. We can still cross multiply, even though, oh no, there's decimals mixed with fractions. That's fine. So we're going to have that the innings pitched is equal to 135 after I do the calculations. 135 innings pitched. So it looks like, I don't know, maybe this was part of a season. We're partway through a season here. Let's take a look at another problem like this. Hey, it's another baseball question. In one season of baseball, a pitcher averaged 8.85 strikeouts for every one walk. If he walked 20 batters, how many did he strike out? That's a lot of strikeouts per walk. That is like Hall of Fame record books level. Okay, so we'll start with how we did the last problem. 8.85, and this is strikeouts for every single walk. K is a strikeout, BB is a walk. Now we're going to do the same thing with the other side. He walked 20 batters, and walks goes in the denominator. And we're looking for how many did he strike out. So that goes in the strikeout portion. And since this is assumed to be proportionate, averaged, we can set up that equation. And we'll rewrite this like we did previously so that it looks a little bit cleaner, and we're just looking at what we want as the only letter. We're using what we want as both a variable here and a unit. So it's nice to rewrite it with the units out of the way. Well, this is simple enough. We're just going to multiply by 20. So he had 20 times 8.85. 177 strikeouts. Thank you, calculator. All right. That's section 4.4. Work hard on it. Word problems are difficult, but when you break them down like this, it can get a little bit easier. Until next time, thanks.